Hello friends, and welcome again to another lab problem set walkthrough. This time we're going to do lab F on the document model and MongoDB. So this is going to be a really cool walkthrough, I hope, and like all of them are. And I guess I'm just going to get started here. So first and foremost, I need to spin up all the goods. Let's get that going. Docker compose, start. I need Jupyter, drill, Mongo app. I don't know if I'm going to use Mongo app, but what the heck, Mongo Express. I really just use Mongo Express as a confidence, like did I complete the task at hand, etc. All right, now that that's started, I can fire up a browser here. I'm going to use my favorite browser to use here, and I'm already in Mongo Express. And here's the Mongo amp, and here's drill, and there's drill, and here is Jupyter Lab. So I have all my favorite tools running and ready to go as per the tools used in the lab. Let's start with the problem set. Use Spark to load datasets, JSON samples, US senators, JSON into the MongoDB database lab F under the collection senators. So first and foremost, I'm going to need to make a connector to MongoDB and get all that stuff figured out. So again, the best way to go about doing this is to use an example. So in the content folder, I could pick F document, or I can also use examples, and then I could use Mongo. Either one works. I think what I'll do is I'll go to the content folder and grab this F document. And what I need is this, right? This is what's going to initialize my Spark session. And what I'll do is I'll make a new notebook here. And I'm going to call this notebook, I'll leave it as untitled, it's fine. What's a bunch of untitles amongst friends? Not much, I guess. And then I'm going to turn line numbers on so that you know what the heck I'm talking about. There we go. Let me just run this again to get the warnings off. Okay, we are ready. Let's do number one. Number one says datasets, JSON samples, US senators, JSON into database lab F. So first and foremost, we got to read this into a data frame. And of course, make sure the data frame actually works. So how about we do that first? df spark read JSON. I don't know if I need multi-line or not, so I'll leave it off for now, and we will just go for it. File. That's the file. And then let's do a df print schema. See what we get. Blows up. Path does not exist. All right. I can't do it this way. I have to give it a full path. So Jovian. There we go. That looks better. Now it's taken a little while, which is a good sign. Okay, and I get back what looks to be like a good schema. Let's take a look at some rows here. I don't need to reload it, but what the hell, why not? What's a couple of extra processing cycles among friends? Yeah, that looks pretty good. Looks like everything came in. Oh, actually, yeah, it looks like it came in. Okay, a lot of repeating data in there. Senator, class 3, senior, whatever. At least these are different addresses, so I know I'm looking at a different person. Think it worked. So now I need to write this to Mongo, and I could do this all in one shot. if I want, but since I have a variable called df, I'm going to use that variable to do this. So df write out to the format Mongo. Why does this work here? Because I did this here. I added that jar. It gives me rights to use this format. And I need to pick a mode. Overwrite. And I need to pick an option. Database labf. And I need to do which collection. And then you need to explicitly call save. Save and load are required for any of these additional connectors that are not file-based. Run that. It grinds. And let's go check it on Mongo Express here. There's a database FDOC, or was it labf is the one I want, labf. And in here, there is a collection senators, and in the collection senators, let's go back, read the stats. There's 99 objects. Okay, so it looks like it worked. Alrighty, that is number 1. So let's find out what number 2 has in store for us. Number 2 says, from the Mongo client, retrieve the first name, last name, state, and party of those senators in either the Republican, Democrat, or Independent party. So I guess I'm just picking one of these parties, and then I'm showing you the name and state of the senator. I guess this is my filter, and it is picking a party. Okay, I can do that. I don't have the Mongo client up, so I'm going to fire that up over here. And that is usually explained up here somewhere. Right here. I'll just copy that, because, boy, you don't want to watch me type that. I'll go to my terminal and give it a paste. And, of course, it didn't work because, oh, it did. Am I in? I think I'm in. Let's just find out. So use labf. Okay, I'm good to go. Let me zoom this in a bit because I'm at the bottom. I'm going to clear it out. I can't do a clear, unfortunately. So I'm at the bottom. Life is where you are. And let's do DB senators. Find all of them. Okay, and then I need, according to the instructions, I need the name. So first name and last name. And then I also want their party, which is up here. So party's at the root, and person has first name and last name. So I'm going to do that first. So find everything. And then I want the following. Party. Let's take that first. Then I want from person, first name, and last name. Those attributes are found inside person. You gotta terminate your curlies. And I didn't do that right. Let's see, I got one extra curly in here or one too few curlies? I got one there, I got one there, I got one there, and I need one more. I still didn't do it right. Because I don't need one here. This is good. Making mistakes is fine. It helps you understand it, right? So why don't I need one there? Because party and person are on the same level. See that? They're on the same level. So they are part of the same collection. They're part of the same attributes in the JSON document. And then these are sub-attributes. I think I have that right now. And I do. All right, there's my data. Now I need to filter it on party, like Republican or Democrat. This is the easy part. So I'm just going to go here, and in this filter, I'm going to put party, and I'll pick the independents. And there you go. You get the 2 independent people. Now, I probably want to know, I'm curious. I would like to know what state. So I'm going to add state. Even though the question has been answered, I'm going to add state. I want to know state. There it is. And that is at the same level as party and person. See that? Same level as party and person. So state. And that'll be the 4th thing I pull. There you go. Okay. Vermont, Maine. All right, so that answers number 2. So there you have it, right there, boom. There's number 2. All right, let's see what number 3 has in store for us. My guess is I'm going to make you create an index or something like that. From the Mongo client, write an MQL index to prove the query performance of question 2. Run the getIndexes function on the collection to prove you created the index and explain or improve to prove the index is being used. So let's start out by showing that the index isn't being used because there isn't one. Let's start out there. We'll turn this into a lesson while we're at it. So I'm going to run this again with explain and then show explain execution stats. So I get these stats here, execution stats, which in there explains how the query gets executed. If you explain without it, all you get is the query planner, okay? Which also says call scan, by the way, okay? That's in there as well, but there's your call scan. The better thing with execution stats is you also get number of rows returned. Number of rows returned is important when you see that you are going through 99 docs and you're only returning 2, you realize that, you know, that's like a 50% weight. That's 50% waste, right? And so you might say, well, whoopity-doo, there's only 99 docs. But again, it's about the ratio, so you need to normalize this. If we scale this to 99 million docs and I am only returning 2 million docs, that is a significant increase in the data volume size and therefore makes a hell of a lot of sense for an index. And I probably would see this in the amount of time it takes to do the query anyway. But this is so small you don't see it, but that doesn't mean you can't treat it like it's big data. You don't need to have pain to know how to improve from the pain, as I always say. You don't need to have big data pain in order to understand how to optimize for big data. As a matter of fact, it's more important to know how to optimize without experiencing a problem. Should you optimize if you don't need to? Absolutely not. However, now, the way that we write an index is you always are going to index on the field that you are filtering. This is indexing 101. This ends up being a key. So we want to rewrite the data along the lines of party, and then therefore we have a new key, and then our index will use that key to find the document IDs, and that will speed up the query, theoretically. So let's do DB senators, create index, and then we want to use the key party. And we're only going to have one here. That's done. Now that that's done, we can run our execution stats again and see that now in the query planner, we're doing an index scan. See that? We're doing an index scan. Now, if you look at the execution stats, it's even better because we are only scanning. Let's find it here. where we're doing an index scan. We have 2 rows returned. We're using I don't even see, I see a seek, right? So, I don't even see a large collection of documents that it has to go through. It's pretty cool. So again, let me do this. Let me do Senator's show index. Is it show index? I think it's, hold on, let me find out. I had it in the instructions. Get indexes. Okay. Yeah. All right, so get indexes. All right. And you'll see that there's the index that's on the ID that's there by default. And then there's the party index. I'm going to drop this party index. I dropped that index. Let me go back to this execution stats. It says docs examine 99. See that? Docs examine 99. Numbers return 2. Let's do this again. Create that index. Run that query. No docs examined. It only seeks to that index. So that's pretty awesome. That's a way more efficient query than one where we are looking at 99 documents, right? What happens with a seek is because, let me see if I can explain this in what's happening here. Because we're asking for this value from this attribute, and we indexed on it, the index is building a collection that has pretty much the 3 different parties and then a ID of each of the documents, and it knows exactly where to find those documents in the collection. So what happens is the index, once we use this independent index, it can seek directly to the location of the documents. And that allows us to retrieve the documents without having to iterate over the collection. Okay, we're using an offset to jump in the physical storage to where the collection is. So again, indexes are so important. This is why I start the class with MongoDB first. I think that it's the easiest to understand indexes, honestly, and they don't go away. All the other databases have indexes. This is a big data thing, although their indexing metaphors are a little more difficult to understand, like when you get to Cassandra and things like that. All right, so we got that done. That's cool. There was a little backstory to go with it. Yay. Let's go to number 4. Use Spark to load the Netflix canceled JSON data sets into LabF under nufcan. All right, let's do that. I'm going to copy this. All right, this is what, number 4? Number 4. So let's do nufcan is Spark read JSON file. And don't forget my home Jovian. Whoop, I need an extra slash in here. And then that. Better make sure I have these, by the way. Let's go take a look. Data sets. Netflix canceled. They are. So, by the way, these are JSON files that I ripped off the internet of shows in 2020 that were on Netflix that are either canceled or scheduled to be canceled. I'm sorry, shows from 2021. So we're going to do a little analysis on these canceled shows. That's what I love about the JSON format, as most of your web APIs return the JSON format. Then the JSON format can easily be stored in a file, or it can be stored trivially in a document database. Leave them on the file system till you know what the hell you're going to do with them. Once you have an idea what the hell you're going to do with them and how you want to query them, maybe you want to put them in a document database to optimize them. I wouldn't even think about putting them in a document database till I had some kind of analytics I knew required the performance benefits of using the document database, because storing them in object storage is 100 times cheaper than using the object database, than using a document database. Again, don't spend other people's money until you have to spend other people's money. All right, let's see if this loads here. So let's do an nfcan print schema. This is usually my hello world of reading anything in Spark. Seems to have worked. I get structure back. Let me see if it looks somewhat right by doing a show. A whole bunch of nulls in here. Something is not right. It's not good. A lot of nulls. So, and I got a corrupt record. See that? When you get this, usually the data is row-oriented, and you or multi-line or something like that. The JSON data isn't really fitting it. So if I'm looking at the data here, and it looks like it's multi-line. No, it's hard to tell from here. If I open it up as a raw file, you'd see it better. But in the root, I have all this data here, and it's just like the next file has the same root. So I need to read this in differently. My guess is it's not compressed JSON format. If I open this up in Notepad, probably would see that better. See if there's an option to use a text editor here. I guess not. Bottom line, if it does this to you, probably try to read it in like this. What does multi-line mean? It means that the JSON has been formatted and is human readable, and therefore you should not treat the end of line character as the end of the JSON record. See what we get now. Oh, see, that looks so much better, because now I'm getting data and not a bunch of nulls, right? So that's just, something that you gotta pick up from experience. That's all. Okay, now I want to write this to a MongoDB collection. And again, the advantage of writing this to a MongoDB collection would be that I obviously want to do some queries on this, and I feel like the queries would run better if they ran on the database itself rather than running in the Spark cluster. For this class, this is useless. You wouldn't need MongoDB. You could just run these babies, have Spark do all the transformations. But again, we're learning Mongo, so here we are. How might I use this in the real universe? Let's suppose I was in charge of I don't know. I had one of these websites where we talked about TV shows. I might use this API to get all the canceled ones and then get some information about the canceled ones. Then I might do some Google searching to find out what shows people are interested in. Then I might turn that into a suggested list of articles that someone should write for my blog, my TV blog, about shows that got butchered and why you should yell at Netflix because it was an awesome show and it should be back on, or some crap like that. I'm just trying to give you a use case that makes a lot of sense. But in that case, maybe putting them in a document database would allow someone to write queries and not necessarily have to use Spark in the process, right? So that's kind of the reason for that. And systematize it a little better. once you learn and know Spark, you'll want to do everything in Spark. I mean, it's just like I said, it's just the way it is. I mean, I am always doing things and then saying, oh my gosh, why didn't I use Spark for that? And it's just embrace the big data-ness of it. Anyway, let's move on and answer the question. So now I need to write this so I'm going to do write format Mongo. I don't know if it's helpful for me to go on these rants or not. I really have no idea. If you don't use mode overwrite, if you use mode append, it's going to keep adding the data over and over again, which is probably not what we want. Nufcan. And we hope it works. And then the way we prove it works is we go take a look here in Mongo Express, right? Or we could use the Mongo command line, but it's kind of convenient to go in here to Mongo Express and look. Yeah. So here's a good example. There's some episodes in here. These are all the episodes. This is true nested data. So one document per show, and then that show has a bunch of episodes. And then if we go past all the episodes, there's even more data. This is a bad one to pick because this one has a lot of episodes. I picked one that maybe has some less episodes. I can go to the bottom. Still, this one has a lot of episodes. Yeah, here's some information about it, right? Runtime, genres, what it's called, what channel it was originally on, etc. Okay, so there's a lot of different attributes in here. This is true document data. Right, that Senator's JSON is like a play thing, but this is like this is what real document data looks like. And document databases are great for storing data as is, but not storing data as is in a cloud storage provider like S3, but rather storing that data as is in a real database so that you can search it or query it as you need. If you need ad hoc query over this stuff, your choices are drill or learn MQL and do it over here, right? But again, you're going to incur costs for putting in a database because the database has a back end. All right. Anyway, end of rant. Long rant. Let's move on to number 5. So number 5 says, using drill, write a query to list the name and premiere date and average rating of canceled Netflix 2021 shows. Limit the rows to those within an average rating with an average rating of under 7. Okay. So a lot of times when I'm doing this kind of stuff, I try to think about, can I write this in a variety of ways? But you probably realize I'm going to make you write this, in Spark and in drill. So I guess we'll torture ourselves with, I should make you write it in Spark, drill, and Mongo query language, but yeah, whatever. So let's do this first in drill. So I'm going to go back to drill here. So I'm going to forget what this is. So hopefully I don't. Name, premiere, average rating. Okay. So what sucks about drill and what sucks about using MQL is you don't get a schema. So one of the nice things that you can do in Spark is you can use that to get a schema. Because you need something to look at, right? So I need the name. Where the hell's name? Name. Oh, that's the episode name. See that? Episode name. Is there another name down here? There's name. Name, that's at the root level. Premiered. Right there. That's at the root level. Where's rating? Rating average. Okay, that's nested. Where the average rating is under 7. Okay, I think I could do this in drill now. Again, without looking at a schema, you're just like shooting from the hip. So let's see what we got here. Let me make sure my connector is configured properly. Mongo. And I have mine configured. So let's try a query here. Select everything from Mongo LabF NFCan. Let me zoom this in. I hate the way the font that drill uses. It needs to be something better. And we're drilling away here, and we get data back. There you go. All right, now we need to take this to step 2, which is we need to get the average rating. So number one rule of using drill is always alias your table. Always. Because you're going to need to do it anyway. Oh my gosh. Mine's like a sieve. Premiered. Was it N rating? Dot. Go away. I don't want that. N rating average. Now, I don't know if average is a keyword or not, so I'm just going to backtick that bad boy just to make sure. Let me do that first. Then I'll add my where clause. Baby steps. Okay, there we go. And now I only want rows here where this average is under 7. Where that average here is under 7. So like this dad stop embarrassing me, gone, under 7. The crew, gone, under 7. Okay. Let's fix it. Where N rating average. Let's try it without backticks to see if it works. Less than 7. Again, this is just me trying it out. Okay, so average works. Okay. I don't like the fact that it didn't. I get this alias there. I don't want that. I'm a professional at this. As average, rating average. Here we go. Like it. Don't love it, but I like it. So there's my answer to number 5. Moving on. Let me go back. There you go. Moving on. Number 6. Using drill. Write a query to list the name, premiere date, and name, premiere date, and genre for only those shows in the history or family genres. Make sure to include a column to display the name of the genre. Oh boy. Oh boy. Okay, let's see what we've got here. Let's go back and look first in Spark because I need a schema, man. Okay, so name, got that. Premiered, got that. Genre. Where the hell is genre? Genre is an array. So I am going to have to use, in Spark, you use explode. In drill, you use flatten. Okay, you got to remember that function that pivots rows, or a nested column to rows. All right, so I'm going to have to use flatten here. All right, I can delete this with confidence, knowing that if I go to profiles, it will have the query in history. So again, don't freak out that you are reusing this cell over and over. Everything you wrote is over here in profiles. Know the drill. I just said a funny. Know the drill with drill. All right, so let's get on and oh my God, I need a vacation. Select name, oh, I should alias, right? So step one, select star from Mongo. Oop, good old caps lock. From Mongo labf nfcan as n. Then I can say n dot name n dot premiered. And then let's just do genre. N dot genre. And I spelled premiered like someone that can't type, and it comes back with no. But if you look, this is what I want you to focus on. This is an array. So I need to explode that out. And the way you do that in drill is with flatten. So I spell this right, Premi Ered. And then if I do in Spark, it's explode. In drill, it's flatten. And that will transform the nested list into individual rows. So now Peaky Blinders is in here 3 times because it was a drama, a crime, and a history. Don't believe me? Because I know you don't, because you also don't believe the hype, right? And genres. Let me put it back in there again. And then we'll keep the flatten in there so you can see what the hell is going on here. So this said drama, crime, and history. So when you flatten it, you get drama, crime, history, a row per each. And that is going to allow me to use my where clause, where I only pick out ones that are family and history. Okay. So now that I have this, I would like to where clause this for only family and history. So if it says history, I want to include it. If it says family, I want to include it. Right? The best way to do that, because I want to where clause this output, is to use a common table expression. This is why I like to explain the rationale behind common table expressions, because a lot of students don't get it. You don't immediately go common table expressions. That's not how you do it. You write a query, you look at the output, and you say, boy, I sure would like to run a query on that output. And then you're like, oh, the solution to that problem is common table expression. So, without further ado, I'm going to call this as genre. Now I'm going to make a common table expression with, and I like to call my common table expression source, because I have a tremendous lack of creativity, but not a lack of utility. So that is now going to be a table called source. It's really a view. And now I can say select, caps lock again, select everything from source, where genre, I can now legally call it genre here, because again, this is in essence a temporary view, where genre in, there's lots of ways I could write this, but I'm going to write it like this, family history, because this is the way I like to think about it. Okay. And I got a boo-boo somewhere. I think I forgot the word as. It's supposed to be with source as. This is completely useless, this parse error. Whenever you get a parse error, by the way, it's just you not knowing SQL. And you just gotta know it. There we go. So there we have it. Now some of these may appear twice because they're family and history together, but it doesn't happen here, but that's okay. It's not really what I was concerned about. So that answers number 6. Awesome. Doing some drill. And there's your answer right there. So I hope I also explained where you implement the common table expression. in that process. 407. Using Spark or Spark SQL, create a data frame or view from Netflix cancellations MongoDB data that shows the name, season number, and episode name, and air date, and average rating for the episode. Okay, all right. I'm going to do this in Spark or Spark SQL. So I guess, I don't know. I'll do it in Spark. Doesn't matter. You can do it any way you want. All right. So first and foremost, this is not from MongoDB. This is from the files. So yeah, there's no difference, but you really want to do it right. So I'm going to call this DF. Let's call it EPS. Let's call it NFCan again, but let's do Spark read format Mongo option database labf option collection NFCan load. Okay, that gets it from MongoDB instead. The reason we are doing that instead of using it from the files is because eventually we're going to take a look at what parts of the Spark query get passed through to MongoDB, right? You'll notice that the projection and the where clause can be passed through to MongoDB. So let's try to solve the problem now. Let's call this EPS. NFCan. I have no idea what I'm up against here. I need to look. Print schema. I need the name. What do I need? Show name, season number, episodes, episode. Whoa, man! I'm just gonna hold on a second. It's too much. Too much for my feeble mind to handle. There. I don't claim to be a savant. That's for sure. All right. So show name. Let's find that baby. I'm guessing that's right here. That's at the root. That's pretty easy. Season number. There's the episode number. There's the season number there. So I'm already seeing that I have to explode episodes. I have to explode episodes to get to tabularize this data down here. All right. Maybe I should chew on this a bit. So let's do this. NFCan select the name of the show. Let's see what we get first. I need to show that, right? Show. Let me turn this off. Okay, there's the names of the show. Boom. I'm going to alias this. So let's do this. Let's do from Spark, from PySpark, SQL, functions, import cal. So that I can do, there's lots of ways I can do this, but I'm going to do it like this. Select cal name dot alias show name. Ta-da! Show name. Why did I do it this way? I could have used object notation. NFCan dot name. Ta-da! I just wanted to use col because col is the way that you continue to use the SQL syntax, but get back a Spark column that you can then apply this alias to. It's nice. So if you don't want to leave SQL syntax because you like SQL syntax, col is your friend. Col's your buddy. I'm also going to need explode at some point, right? Let's add that in there. Okay, so let's try to add an explode in here. I already forgot what it was. The array is in episodes, embedded episodes. Okay, let me try this. Breathe easy. Explode, embedded episodes. Dot alias episode. And this is already too much to chew on because of my zoom level. So, boop, bing, bong, bong. Let's jazz it up. Bing, bong, bong, bing. Dot show. Please work. There you go. There's my episode. Now, it's nested all the hell, isn't it? It's, you know, it's gorily nested all the hell. But here's the pro tip for using Spark. Any SOB you get back, you can then run print schema on to figure out what the hell you got. It's like so useful. Okay, so I got one column is show name. The other column is an episode that contains these things. I don't know. I think this is cool. And then with that, I can then run another select. And then I can ask for show name again. And then now I want... Oop, son of a pup nugget. Show... or episode. I lost it now. Because I fat-fingered and ran it. I want to... Now, if this is too much for you, you can just like say, oh, I'm going to store this in some temp. Right? And then you can come down here and say temp.select. Oh my God, stop hitting the enter key, Mike. Good Lord. I need my charge card taken away from me. Someone needs to tell me to stop. So I'm going to do this and try really friggin' hard not to hit the enter key this time. This new keyboard sucks. Actually, my typing sucks, but the new keyboard makes it worse. And then I need episode. Episode. And then what do I want again? Oh man, I got to go back and add. Oh, it's up here. Season number. Episode number. Episode name. So episode. Where's name? Name. Episode. Season. Episode number. What else? What else did this evil person want? Air date. Air date. And then rating average. Zoom this. I mean, why is this over here? I don't even need this over here. Turn that off. Left status bar. Get out of my way. Sidebar. Get out of my way. Episode number. Episode. Air date. Episode. rating average. I'm going to go for the home run here. Baseball metaphor. Just going to swing for the fences. Zoom that out a bit, and then let's show that. And I got to turn off this print schema here so that I don't have to see that. All right, now we're getting somewhere. So here is the show name. Here is each of the episodes. Here's the season. Here's the episode number. Oh, this is the name of the episode. That's a pretty lame episode. See, then they start to get better. The Noose, Heathens, right? And then here is the air date, and then here is the average rating of that episode. All right. So what I want to do is do it all in one step now, so I can eliminate. If I don't really care, I can just put this in a data frame called, EPS. Okay, and then now I've got, take the show off, and now this cell gives me EPS. Now, if I don't like name, I want it to be EP name, I can then fix it here. I could say col, episode name, alias, EP name. And then now it says EP name. See that? So you get a lot of utility out of doing that. If you are having trouble writing don't feel like you have this need to be like super macho Spark programmers and like do it all in one line of code. That is not who we are. You should embrace this idea if it works for you. Don't feel the need to be, this macho person. All right, let's see what we got next. Using the query you wrote in question 7. Okay, this is screaming create or replace temp view, or it's screaming go ahead and save it in a data frame like I already did. Write Spark or Spark SQL to get the lowest rated episodes of each season for canceled shows. So I want to find the episode that has the lowest rating. So I need to find the min average rating, but I also want to show the show's name. So normally something like this, I think, requires a window function. No idea how to do that in regular Spark, so I'm going to dip into my Spark SQL bucket and do it. Just don't know off the top of my head how to do that. Again, because what you want to see here is you want to see the name of the show, the season number, the episode name, the air date, and the average. I'm down here. Because you want to see the show name, season number, episode name, and rating for that episode. But I want to show the lowest rating along with that over the season and then pick that. So I can't do a regular just group by here. Or maybe I can I? Can I just say select min and then group by the other columns? Show name, season number, episode number. Maybe I can do that. Maybe I don't need to use a window function. I don't know. These are things that are like, this is what happens with ambiguity, right? You just have to kind of figure it out. What do I really want to see? Let's go back and look at Spark, right? So let's go down here to EPS show. Let's pick one of these, and I'm just going to paste this in up here like this so we don't forget what the hell it was. Lowest rated episodes of each season. So season one, the lowest rated episode is, the lowest rated episode of season 1 is this first one. But I can't show the episode number Because if I group by that, I'm going to get all the episodes. So I am going to need a window function, right? I'm going to need a window function to generate a column that gives me the min average over the season, over the show name and season. And then from there, I can use a where clause to find the minimum. Okay, so this is going to be like a two-stepper again. So maybe a common table expression or something. I have no idea how to do a window function in Spark. I could Google it. I just don't feel like it. I'm going to use create or replace temp view. See, I got this up here. Yay! I'm no dummy. All right, here comes my window function. So I want the min of average over the partition by show name and season, right? Because I want the worst episode in the season as lowest rated in season. Blows up because I don't have a from clause. Moron. From apps. All right, there we go. So season. All right, something's not. Well, no. This is right. Right? So if I look at season 5, right, there are 6 episodes in the season. The worst rated episode is right here, 8.3. So let's go find something that's an utter dumpster fire here. Like maybe I'll take this one, The Crew. Oh, Last Kingdom works. So the worst episode here was 8.6. Wow. Got a pretty good rating. It still got canceled. Oh, well. All right. So now that I know that this works, I want to filter this data to only show the one episode that was the worst of the season. And I want to show the episode number. So like episode 6 was the worst of season 5 or whatever. Okay. So I am going to need to query this. So I now have a choice. I can take this query and make a create or replace temp view and then query that. Or I can now flex my common table expression muscle again. And I will choose to flex my common table expression muscle. So with source as this crap, select star from source where lowest rated in season equals average. And just for kicks, let's order that by show name and season. So that, because this one's season 5 came first. That doesn't make any sense to me. That's what threw me off. Okay. And pow. Takes a while to run this crocodile. All right, there we go. So now I have season 1, episode number 1 was a 5.3. Season 1 number 2 was also a 5. These are tied. That's okay. Let's see. Season 2 episode 7 was a 7.5. These are all 7.5s, right? So this is working. I get repeats, but I'm going to get repeats because, you know, they have the lowest a couple times. It happens. All right. Looks good. So one thing to note is I don't have to show this. I can stuff this in a data frame. You know, df equals this. And then now that it's in a data frame, I can do whatever the hell I want with it. df dot show, you know, df dot print schema, df dot explain. Check this out. Ooh. But if you look through this scan where it goes to Mongo, is it passing in a filter? Let's see here. Pushed filter. It's only pushing a filter of not null on embedded. So this is not a very efficient, unfortunately, this is not a very efficient Spark / Mongo query because we are filtering after we do the explode, and the explode is being done by Spark, not by Mongo. Okay, so those are things that you kind of have to understand when you end up doing this for a living, and you know you're making way more money than your professor, and you're doing this at your 40 to 60 hours a week because you're overworked. You can come back and talk to me all you want about how expert you are at this. And how much better you got at optimizing these things. But, you know, for the meantime, there might be a better way to do this, maybe with some direct Mongo querying, but you can't use the Mongo query language with Spark. So there's no option there, unfortunately. All right, let's see what else we have in store. What other cruel things did I do? It says challenge yourself. Display the name of the show, a picture of the show, and a show summary. Make it interactive so you can select the show and see the details. Okay, I'm going to have fun with this. This is, once again, an exercise in small data, and it's going to use that IPython display. So let's go down to this last cell down here, and I'm going to do the usual from IPython.display. I'm going to import display, HTML, and the image utility. And then from IPyWidgets, I'm going to import interact. I'm going to use interact. Interact automatically will call the function onChange instead of onClick. I'll do interact and interact manual to show you the difference. I know I'm going over time, but whatever. That works. So let's just do this. Let's display in a huge heading. Netflix canceled shows of 2021. Little HTML here. Boom, love it. Let's get a list of shows. So I'm going to play around in this cell and then put it up here when I figure it out. So we got nfcan, select the name of the show. Oof. The name of the show. I want distinct names. Okay. Those are all the distinct names. I want these in a Python list so that I can feed them into a UI. So let's take those distincts. Let's sort by name. Then let's get that into pandas. Make it small data. There they are. Now that I've got them, I need to make them into a regular list. So the way you do that is in pandas, you say, just give me the name column and give me the values in the name column. So this actually ends up being, I know it's ugly, but this gives you boink, big data, small data, just an array of those values. Okay, so I'm going to call this shows. I only really got to run this once over my data. There's no real point in running this every time. So now comes the interaction. So the way you build the interaction is as follows. You say interact manual. Manual means I'm going to have a button. Interact means there's no button, and the minute I change a widget, it's going to rerun the interaction. So I'm going to do it this way. And I'm going to say show, and then give me a list of shows. And then now I need to write a function that runs every time the interaction changes. So I'm going to call this function onChange. You can call it whatever the hell you want. I'm going to call it onChange. And I'm going to pass into it a show. And for now, what I'm going to do is I'm just going to display the show. So get this working. Right, grinding away. Then we get the show, and then every time I change it, see it changes automatically. See that? Is there a way to get rid of that pink warning? Probably. I just don't care. Those are hair-splitting things. All right, now I want to tell a nice story. Maybe I want to say, give a synopsis of the show. Maybe give the rating of the show. Maybe print a picture of the show. That kind of stuff. So let's do this. Where can we flesh all that stuff out? Let's do this. Show details. Show info. Let's just call it info. Info is nfcan where nf. Let's just use SQL syntax. Name equals show. And this is going to be an F string so that it passes in show name. And I think this is going to have to be in quotes because it's a piece of text. And then let's just put that in small data. And let's see if that works. Oh, I don't have a show because show's in here, so I need to pick a show. Let's pick, I don't know, Zero Chill. See that? Let's test this out. Oof. This is not what I wanted. Thank you, copy paste buffer. There we go. So here's the data I get. Let's extract out the goods that we want. So, what do we got in here? I got, what do I got? Let's go with the show name. Now, I might want to select only the things I want, right? Because that's a good idea, is don't turn all of your big data into small data. Turn only the big data you want into small data. So in order to be better at this, maybe I need another cell here. Maybe what I need to do is nfcan, print schema again. I need, let's see, I want to show there's the image. I'll get the medium image. It's going to be smaller. Let's get the name of the show, the rating of the show, a summary of the show, maybe the date it was canceled. Is that in here somewhere? Ended. Okay. Name, date. I'm just going to put them in there. Let's just make it happen. Leave this here. Select name. Oh, let's bring in the URL. Why the hell not? Nah, I don't want that. What did I say? I wanted summary. I wanted image medium. Image medium. And I also wanted the status of it. And I also said I wanted the average rating. Rating.average. Rating average. Again, the rule of thumb is only bring enough. I mean, this is small data to begin with, but we only want to bring enough small data down. Bring as little small data down out of your big data. That's a good rule of thumb. So let's see what we get now. So this means I get less. There we go. Now I have some manageable big data. Okay. So let's continue with the. Now that I got that figured out, okay, I can get rid of this. This can go. Just cut that out. Okay, now I can configure down here. So let's display in HTML a heading, I don't know, 3. And let's put the title of the show in here, which is going to be, first of all, I need to do this, right? And then let's get the title of the show. So you might think, by the way, this is like not a Spark problem. This is a Pandas problem. So how do I get this column, right? And you might say, well, that's easy. I just do this. Info name. Check this out. Let's try that. Oh, I got to put an F string out here. Interpolate this bad boy. There. It's running, and then I get black AF name D type object. This is the entire column info, including the series number. So if I want the value out of here, what I need to do is tell Pandas to just give me the first row, even though it only returns a row. So the way I do that is with iloc. This is what I love and hate about. This is what I love about Spark and hate about Pandas. Is like Spark is just so intuitive. Spark data frames so intuitive. Panda data frames not necessarily. So this iloc says just give me this row of data out of here, the 0th row, which is the 1 row, and then that way when I do this info name, I just get 0 chill. I don't get all this other metadata associated with the data frame. There we go. Now it doesn't like that apostrophe in there. See that? Blows up on me. So I probably need to be better with, where is it? Here. That's not gonna roll, that's not gonna work. So I need to change this to nfcan.name equals show like this. See, this is the problem with the SQL syntax. Sometimes the SQL syntax blows up in your face. Let's see what we get now. Boom. And then Jupyter's legacy. Now that works, right? Because now it's just comparing the variable to that. It's not passing it in, making a string out of it, then interpreting the string. Okay, it's time for the image. display image. Now, when you display an image in IPython, you give it a file name, which is a local file, or you can give it a URL, which is a place on the internet where the image is. If you look here, it's a URL. See that? So I want to say URL, and then in here I want to say info medium. Because that's the column name. Let's see if this works. There's our image. Wonderful. How about, let's change it. Boop. Look at that. Nice. And now let's do this. Let's add the other pieces of data in here, which is status, canceled, right, rating, and then let's put a summary below it. So above this, display, we'll use HTML again. Let's just put in a, whoopsie daisy, let's put in a paragraph, and let's say status. Let's do it in bold. Now let's do it like this. Status. And then in bold, let's put in the image, the info status. And then after that, let's put rating. And then in bold, let's put, one thing I'm not very good at is like making stuff look nice in HTML. But, you know, hey, I'll leave that to the designers of the world, which I am not. Info. I may, hey, use Bootstrap, done. There we go. Perfect. Status ended, rating 4.9. Status ended, rating 6.2. Now underneath, I want to put the details. And the details already are in HTML format, as you can see. There's markup in here. So I just want to do this. Display HTML f-string. I'm not even going to bother with f-string. I'm just going to go info details. Or it's summary. New money and expensive taste. Blah, blah, blah. Blah, blah, blah. Blah, blah, blah. And I want to get rid of all this stuff down here because it just makes it look ugly. Look at that. Data product is what you made here. Now, this is kind of cool. I don't know, I'm having fun with it. You know? So there you have it. Small data, yay, right? So the number one rule when you go from big data to small data is take as little data as possible. Do most of your transformations in big data, and then get it down to small data. And then same thing here. Most of my transformations in big data, get it down to small data. It really, honestly, it does depend on the data size. This data set's so small, none of it needs to be big data. But again, imagine that you have 20 years of canceled shows across Netflix, Amazon, Hulu, CBS, NBC, every show that was ever out there. That might actually kind of be big data. And so doing it this way would save you a lot of time and effort on the client, as opposed to taking the entire thing and putting it in pandas and then doing the filters. So that's where it works. Now, obviously, we would probably not use a drop-down in that case. There's too many shows. We would use a text box that you would type in the name of the show, and it would do some kind of search. But it would work very similarly. It would work very similar to this. Okay, that's it for this week, I think. right? That's it. That's all of them. Thanks for watching, and hopefully you learned a lot in the process. Bye.